Thank you all very much. Most of you probably do know me from Breakfast Radio, but before I got onto that, I still am, and I always will be, a mathematician. And for anyone who's been bitten by the numbers bug, you'll know that it bites early and it bites deep. For me, I was in second grade at Boronia Park Public School. And our teacher, Ms. Russell, said as we came into lunch one day, "Year 2, what do you want to do after lunch today? I've got no plans, it's over to you." It was an exercise in democratic schooling, which was pretty cool. We were 7 and made a series of ridiculous suggestions for how we could occupy ourselves through the afternoon. Finally, a frustrated Ms. Russell said to one student, "That won't work. That'd be like trying to put a square peg into a round hole." I thought about it for a couple of seconds, put my hand up. She said, "Yes, Adam." And I said, "But miss, surely if the diagonal of the square is less than the diameter of the circle, well, the square peg will pass quite easily through the round hole. It'll be like putting a piece of toast through a basketball hoop, wouldn't it?" There was that same awkward silence for a couple of seconds before Stephen Capper, one of the cool kids in class who was sitting next to me, leant over and punched me really hard in the head. Now, what Stephen was saying was, "Look, Adam, you are at a critical juncture in your life here, my friend. You can keep sitting here with us, or any more of that sort of talk, you'll be sitting over there with them." I took a moment, I looked at the road map of life and ran off down the street marked geek as fast as my chubby, asthmatic little legs would carry me. I was in love with numbers from the youngest of ages. I used to say to my friends that numbers are the musical notes with which the symphony of the universe is written. And I was saying that for years before I even discovered that one of the greats, René Descartes, said very similar. The universe is written in mathematical language. I was thinking of suing him, but I think he said it before me. Today we're going to hunt for one of those amazing, beautiful musical notes. We're talking prime numbers. Don't freak out. 6 is not prime because it's 2 times 3. 7 is prime because we can't break it down into smaller factors. It's simply 1 times 7. 3 things to know about prime numbers. 1 is not a prime number. Happy to explain why later. 2, there's an infinite number of primes. They go forever and ever. The great mathematician Euclid proved that, 300 BC. And 3, as mathematicians, we've always wondered, well, what's the biggest prime number we do know of at any moment in time? And all you need to remember from all of high school maths to follow me today is this. When I say 2 to the power of 5, I'm talking about multiplying 2 by itself 2 times 2 times 2 times 2 times 2, 5 times. So 2 to the power of 5, 32 minus 1, 31, happens to be prime. And for reasons I won't go into, most of the monster primes we've ever discovered are of this form. 2 multiplied by itself a prime number of times, take away 1. Now 2 to any prime minus 1 isn't automatically prime. 2 to the 11 minus 1 is 2047. You don't need me to tell you, that's 23 times 89. But 2 to the 13 minus 1, 2 to the 17 minus 1, 2 to the 19 minus 1, they're all prime numbers. And this search has obsessed some of the great mathematicians. Leonhard Euler, so great that other mathematicians said he is the master of us all. A man so amazing they put him on European currency back before that was an insult, proved that 2 to the 31 minus 1, it's over 2 billion, he proved it's prime. What the heck? We know that 2 to 127 minus 1, a monster number, 39 digits long. In 1876, a guy called Lucas proved this was prime with nothing more than pen and paper. Word up, L-Dog. What an amazing achievement. But as with so many sciences, along come computers and the game changes entirely. The largest prime we currently know, take 2 and multiply it by itself 43,112,609 times. Take away 1, you've got a number that's almost 13 million digits long. Here's just 1,000 of those digits. If I was to show you this entire number, I'd have to put up a screen this large every second of every minute of every talk you'll hear for this afternoon, all 3.5 hours, including interval, and I would just manage to show you that number. And as I stand here, I know it's prime as confidently as I know that 7 is prime. I find that beautiful. I find that almost sexually exciting. I know many of you say, Adam, we're happy for you, but why should we care? I'll give you two reasons. First of all, testing massive primes is a simple and beautiful way to test the power and speed of potential new computer chips. But secondly, this prime was found as part of an international search. While I'm here talking to you at home, my computer is part of the GIMPS project searching for giant primes. In the same way that other people around the world on their laptops, on their workstations, are searching through data for RNA patterns, are searching for signs of extraterrestrial life. Distributed computing over the next 10 years will see scientists around the world looking at your laptop, looking at your workstation, looking at your computer and saying, I want its grunt. I want it to find things for me. Some of the great discoveries of the next 20 years will happen on your computer, on your laptop, in the palm of your hand. But for me, it's enough that this beautiful, beautiful number, this magical note, was lying out there. It has been since the dawn of creation. And finally, we found it with the power of the human mind. I think my friend Descartes would probably put it this way. To find a number like that, to find that musical note, is the essence of human being. We think, and therefore we are. Thanks a lot.